So in this session, we're going to look at using third-party authentication in our installable cloud apps. And perhaps third-party isn't the appropriate verbiage here. Maybe what we should be saying is alternative authentication as opposed to database authentication. And we'll cover that in a few minutes. So first thing we're going to have here is a disclaimer. And let's look at the session agenda. So I'm going to talk about myself for a little bit, just so you know who I am. Then we're going to look at JSON Web Tokens as an authentication approach, OAuth. And then we're going to look at Amazon Cognito and Microsoft Azure AD specifically as another approach. So Amazon Cognito and Microsoft Azure are definitely third-party approaches, but JWT and OAuth are just alternatives to database authentication. So a little bit about me. My name is Bruce Armstrong. I've been using PowerBuilder since version 1, actually. A few of the languages I'm familiar with are listed there, as well as a couple of open source projects, PowerBuilder related open source projects that I'm involved with. A little bit about the company I work for. If you want to know more about us, you can look on our website. So let's talk about JSON Web Tokens first. This is the flow diagram for how JSON Web Token authentication works. And so what we're going to do, it starts here with the client, is we make a request to the JWT Auth server. This is operating within PowerServer. There's one built into PowerServer that you can use. That gives us back, somewhere in there we authenticate. We might go to the database to authenticate. One way we could do that is we could actually go ahead and do a database connection using the user ID and password. If you still want to use a database account-backed authentication, that's not very it's not very performant, and depending on your database, it could require that you maintain named user accounts that you may have to pay for. And so another approach you may want to look at, and this will be the same with OAuth, is you may want to create a table in your database of your users and their passwords in an encrypted format. And then what you would do here in the auth server is take the password that was sent to you and compare it to the unencrypted password. You retrieve the encrypted password from the database and unencrypt it and compare them, and that would validate the user. So that would be one way to do it here. Anyway, the user gets a token back, the JSON Web Token, and they take that request and they send it up to the web API on every call. That token is continued to use then over and over again to authenticate the client every time they ask for data. And what the web API does then is it takes that token and asks the auth server, is this token still valid? And gets a response back. If the token is still valid, it goes and gets the data from the database and sends it back down to the client. As you'll see here, once we get into the sample code, these tokens have a lifetime. And what you can do in the client is you can monitor how much time has expired since you requested the token and then refresh the token. So you make this call again to get an updated token and then use that new token for any subsequent requests. So you're always working with a valid token. So that's how JWT works. So if we're going to do that with our PowerServer client, what you would do is you'd come into the Web API tab on your PowerServer project. Normally, when you start off, this says no authentication. And what you do is you change that to say you use a built-in JSON Web Token server. And if you're going to use the JSON Web Token approach, you're going to need a couple of things here in the runtime libraries. you'll need to check these. If you're not using them for some other purpose, you're still going to need them to do the JSON Web Token calls. One is the REST client, and the other one is compression. So this next property we're going to look at, this applies no matter which of these authentication methods we're going to use. What you need to do is go into your application object, go into its additional properties, go to the PowerServer tab, and there's an option there that says start session by code. Let me zoom in for a minute. There, begin session by code. So you would make sure that is checked. So what PowerBuilder does, if you weren't using an outside authentication mechanism, is it would create a session on the server automatically. This says we're gonna manually start the session from within using a PowerScript call, and we'll see that when we get into the sample code. This is some instance variables I've created. Now, what's different with this sample code I've created is I've actually created code that demonstrates all the different methods. So, I mean, your app's not going to do that. You're going to pick one method for authentication and just use that. So you're not going to necessarily have some of these instance variables that I've got here. But and this is instance variables. This is a PFC-based application that I'm modifying, and in a sense, you can actually do this in your framework layer. Now, I didn't do it quite in the framework layer. I did it in the application object that's specific for this this application. But you could instrument this right in your own framework, and that way all your applications would use whatever approach that you're going to use, and you don't have to put in the code really once. So what I've got here, I've got a variable that indicates when the token expires, and then there's this value, it's called a clock skew, and basically it's a buffer that you want to allow between the server and the client as far as the current time. Because let's say you get a token and you say that token expires in 3 minutes. Well, if the server is 3 seconds ahead of your client for a certain point of time there may think that it's operating with a valid token when it's not, because the server has already decided that token's no longer valid because it's using a slightly different clock time. So this clock skew is the difference that you're allowing between the server and the client. In other words, what you're basically doing is you're expiring. You're having the client think that the token's expiring a little bit early to make sure that it's not thinking that it's got a token that's valid when the server's expired it. Now, PFC keeps track of the username that was passed in, an instance variable already. So I just added one to keep track of the password, because we're going to use that later on when we re-authenticate the token. So we're going to take the password that they passed in and use that when we do the re-authentication. And then, now this is one you wouldn't have. This is I just have it because what I do in the INI file is I set a value that indicates which of these different authentication methods I want to use. And then later in the code, I do a choose case on that and call the appropriate code to do the authentication using that method. So you wouldn't have that in your code. This is just for the sample code. So this is an example of the specific code that's used for JSON Web Token authentication. So I'm going to take the username and password that I got from the login screen. I'm going to put them together in a specific JSON format. I'm going to create a REST client, I'm going to set the request header to application JSON, and I'm going to make a get JWT token call. So there's a specific call to get a JSON Web Token from the server. This server URL I have in the INI file, and it's just a path within the PowerServer project. You'll see that in a minute. I'm going to pass in that JSON data, and I'm going to get a response back from the JSON Web Token server in PowerServer. I'm going to create a JSON parser. I'm going to load up the JSON response I got back from the server into the JSON parser, and I'm going to look to see if I got the token type in the access token. If I did, what we do then is we take our application object and we do a set HTTP request header on it. That means that what the application object will do is anytime that a REST client is used after that, it will automatically add this authentication header to any request being used by that REST client. We don't have to do it each time we set up the REST client. The application object itself handles that. And then I look for the expiration date of the token, or time, I should say, the token, and store that off so that we can do our token refresh before it expires. What I'm doing here, and I'm going to zoom in on this a little bit, is this is in my application object. I'm doing a insert object, and then down near the bottom, timing object. So I'm creating a timing object on the application object, or in this case, the application manager in a PFC app. In the timer event for that timer object now, I'm going to check to see what the authentication method is, and depending on what it is, I'm going to call the appropriate authentication method to get a new token. So once again, your code wouldn't have this. It would just have one of the calls, depending on which particular authentication type you wanted to use in your apps. This is the StartSession method on the that's going to get we're going to use to start a session. Since we turned it off, we turned off the automatic session creation in the application object. So what I'll do is issue a begin session on the application object, and just checking for errors here. And then if our token has an expiration time, this refresh token is the name of the timer object, and I'll just tell it to start. And this is where we take the time it's going to expire. Let's say that's 3 minutes, but I'm going to subtract 3 seconds from it, so that the client actually expired. Doesn't expire the token, but it thinks the token's expired before it actually is, and does the re-authenticate. So this, what happens is when that timer event fires on that timer object, we'll do that re-authentication to get the token again. The note up here, regardless of which authentication method you use, you're going to have this code. This code's the same for all the approaches, and this is also the same for all the approaches. Some new error codes have been added to the system error event. The system error event. And what you can do then is check the range that the error message falls into. And so if it's between 220 and 229, that means there's session error, and then the license error for 230 to 239, 240 to 249 is a token error of some kind. And the text will tell you more specifically what the particular error is there. in the case of a token error, that's likely going to be that your token's expired, that your clock's skew maybe wasn't high enough, and the server went ahead and expired the token. And so when the request went up to the server, the server said that token's no longer valid, sends back the token error, and so what we'll do is we'll just automatically re-authenticate. And then if it's none of these, then you go ahead and, in this case, I'm using the PFC, so I can just call the ancestor PFC system error event. Okay, this is the login, and this is PFC based again. So here's where I'm reading that INI file to figure out what my authentication method is going to be. So you wouldn't necessarily have this. You would already know that there's a particular authentication method you're going to use. Up here, I'm checking to see if it's a PowerServer app. What that allows me to do then is I can use the same code base, and I can continue to do a client-server application and do a PowerServer application that uses third-party authentication here. So there's an else block down here that just does a normal database login for the client-server code. But anyway, I'm reading off the authentication method, and I'm doing a choose case based on it. And there's a case for each of the different methods here that calls just a specific authentication method for each one, and then calls that start session, which I said is used by all of them. So this is where we check to see if we're using JWT and do the JWT authentication call. This is an example of what's in the INI file. So here's where I've got the authentication setting. So in this case, I've got it set to Azure. So it could be JWT, OAuth, Azure, Cognito, or database, and it just does a standard database authentication. And then depending on the authentication mode that's being used, I read a different section here to get my my token URL, the URL I'm going to call to for the server that's going to do the authentication. And it just so happens that for JWT, OAuth, and even for Cognito, we're calling it a server that's within the PowerServer CSharp code running in the middle tier, and it actually is the same URL in each case, but I wanted to leave some flexibility there. In the case of Azure, we are going totally outside PowerServer. We're going to actually call the Azure AD directly to get the token in that case. So we're going to make some changes to the code that's generated here. Let me get all this up. So a few things to look for here. You're going to get some code that's generated that's not quite complete. So there's a authentication extension file, and that's what we're looking at here. And what that does is says, how do you want to validate the user? And it gives you a couple options here that are generated by default. One is a default user store, one's called a database user store. So the default user store is just a list of users and passwords that are just hard-coded into that C# file. That's not something you're really, I can envision you're using in a production database, but it helps for demo purposes, and it's actually what we're going to use for the demo. So by default, this line is actually commented out here, and I've uncommented it to indicate that we're going to use the default user store. The database user store assumes that there's some table in the database that you're going to select from to get the username and an encrypted password, decrypt the password, and then compare it to the user ID and password that were passed in to do the validation. But it's still a bit of a framework, and you still have to define the table and the select statement you're going to use, that kind of thing. So there's a little bit left to do here to get this fully implemented. And then, like I said, for the demo here, all I'm going to do, I'm going to take the default user store, but it created a couple of users, but it's not the users I wanted to use. And so I updated that file to include the users I wanted to use for the demo. So let's go ahead and look at an example of the JSON Web Token. Okay, so this is going to be the JWT option. You can see I've got built-in JWT server. One thing you notice if you look at the sample code is that I've got each solution in a different folder. What I have is in the INI file, I indicate which authentication mode I want to use. So the one thing you have to do when you're using the sample code is make sure the INI file authentication is changed to whatever one of the different example projects you're working with. So let me run the API here. And run the client. And then I'm going to fire up Fiddler here as well, because if I just log in, that message is coming from Fiddler because it's using a self-signed certificate. It just works, and so it's not entirely obvious what just happened there, but let's take a look at Fiddler. And so what you're going to see here is there is the token request being made. Okay, and we get the bearer token back. We'll review that in JSON. Okay, and then this is the next call that's made. This happens to be the create session call, and there's a bunch of other API calls being made down here. But notice now what we have is a bearer token on each request, which is the token that we got here. And there's your expires in. So that's, I'm not sure my math. That's in seconds, but I'm not sure the duration there because I can't do the math off the top of my head. Anyway, the other thing you can do here is you can actually look at the output here from the server, and you'll notice that way up here at the top. Down a little bit, you should see the JSON Web Token being being called, and then that's actually the create session. So this is where the bearer token got passed in. But here's where the token request was made. So you can see that in the output from the server as well. So that's JSON Web Token. Okay, so that was JSON Web Token. Now we're going to look at OAuth. And OAuth is very similar to JSON Web Token. There's a token request going to the OAuth server, a token coming back. The OAuth server is going to have some means of authenticating the user. The client then takes that token, sends it in with its data requests. The token's validated against the OAuth server. If the token is valid, the web API gets data from the database and sends it back to the client. All very similar. Just little minor details on how the call is made to the OAuth server. The one thing that's going to be different here is that when in our PowerServer project, when we go to the auth template, we're not going to use JWT. We're going to use OAuth server, use the built-in OAuth server. And in the runtimes, instead of the REST client, we're going to use the OAuth to support option instead, because we're going to use the OAuth client in our code rather than the REST client. Compression support is still needed. So those two options. So here's what the code looks like for doing an OAuth call. So we create a token REST object and specify the location as the URL in the server that we're going to call, indicate it's going to be a post, client ID of ro.client, the client secret, and then a scope, the grant type, a password, and that's how we know that we're going to have a user ID and password that we're passing in. So we're going to take the user ID and password that came to us from the login window and add them to this token request. We're going to create the OAuth client. One of the methods of the OAuth client is access token, where you send in the request, you get a response back. The response is actually an object, though. So, with the JSON Web Token approach, we use the JSON parser to get the results, pull the results out. With the OAuth, we can actually pull them directly off this object that was returned to us. So we get the token type, get the access key, call that same set HTTP request header on the application as we did for the JSON Web Token, and once again pull off the expiration date and store it in the instance variable. So yeah, it's all very similar code. And once again, we'll be making changes to the web API CSharp code that's generated. Once again, the authentication extensions indicates what we're going to use to authenticate the users. And once again, I'm going to use a default user store and populate it with just a bunch of hard-coded users. And once again, you could have a database user store that goes and authenticates them against the database somehow, usually a table in the database with user IDs and encrypted passwords. Okay, so let's look at a demo of OAuth. This is the OAuth example. Now this one's going to be a little disappointing compared to the others because you'll notice that I've got listening to HTTP rather than HTTPS. And the reason for that is that when the OAuth server in PowerServer attempts to validate the token, it's crashing on the self-signed certificate for this local machine. And I'm not sure why the OAuth server does that and the other servers don't. That is the case, and I'm sure it's just a minor configuration issue someplace that I haven't had time to resolve. So rather than listening on HTTPS, I'm just listening on HTTP, and I'll go ahead and run the client. And so all we're going to see is that we can log in. And we can examine the logs and see that there was somewhere in here that there was an authentication request. Farther up. There we go. That's a little bit more information. There's the request coming in right there. So I actually logged out a good deal of information here to the log. Unfortunately, at least currently, I don't think it would work with Fiddler running. Let me try that. Oh no, it won't work with Fiddler running. And the reason is because we're using localhost, and localhost bypasses Fiddler. If we're going to use Fiddler, we'd have to use the IP address to do the connection. But like I said, that causes issues. So anyway, that is OAuth. Okay, so that was OAuth. Now let's look at Amazon Cognito. Now things change a little bit. What's going to be the same is that we're going to send a token request to the Cognito server that's built into PowerServer, get a token back, send that along with all our data requests. The token gets validated internally, and if the token is valid, then Web API goes and gets the data and sends it back to the client. What's different here is that we're no longer relying on the database for validating our users. We're actually going to go out to this outside service, Amazon Cognito, and use that to validate the users. So that what that means is you're going to have to go into Amazon Cognito, define the users, give them passwords, all of that. And that does sound like a little bit of work involved, but there's some sort of upsides to doing that, because Amazon Cognito is going to basically handle all your user definition, the authentication, their password resets, their password changes, all of that for you. For instance, if you want to do multi-factor authentication, if you want to have an email sent to the user with a code that they have to add, they have to specify in addition to their login information, or send a text to them that they have to validate, Amazon Cognito will handle all that for you. You just have to define it when you set it up. If the user needs to change their password, they can do it through the Cognito website. If you need to reset their password, you can do it through the Cognito website. You offload all that password account, all the user account management to this third-party service. And it provides some additional features such as the multi-factor authentication that's not available to you when you're just working in PowerBuilder. So that's how that's the kind of the overview of how it works. Let's go to see how we actually do this. And first, I've got another disclaimer. And this is just my personal feeling about Amazon Web Services. They're great, but it's like, I think the analogy I would give you is it's like Legos. So you can take Legos and you can create a car or a plane or a spaceship. You get all these little tiny pieces and then you can put them together and you make whatever you want out of them. The problem is you need to know which pieces you're going to use and how to put them together to make the result you want to get. And that's not always really obvious when you're working with Amazon Web Services. So for Cognito to work, there's actually 4 pieces that actually fit together. One of them being obviously Cognito. But we also need to work with Amazon Web Services organizations. In fact, that's our first stop. We have to create an organization. But we also have to work with Amazon SSO and their identity and access management services as well. And it's not really, like I said, out of the box, it's not really obvious when you're working with Cognito that you need all these pieces, but you do. That they all work together to make Cognito work. So the first thing we're going to do is go ahead and create an organization. Okay, this is in the Amazon Web Services console. So click on create. Well, then we're going to create a new application in Amazon SSO. And what we want to do is specify that we're going to add a custom SAML option. We're not going to select any one of these options down below. We want to do a custom SAML option. Okay, we're going to give it a name, a description, and for the application metadata, we want to click this link that says that you want to type it in manually. And what we do is provide these values. So there's 2 values it requests: the application ACD URL, and we'll just put in the sign-on slash SAML. And then for the SAML audience, we'll just put in Amazon Web Services and then save that application in Amazon SSO. Then what we want to do is download the metadata. So I'm going to zoom in on this again, make it a little more obvious what's going on. So this is your custom SAML2 application you've just created in Amazon SSO. Go to the configuration, and next to this SAML metadata, download this file. And there's a couple places we're going to use that later on here. So now we have to go into identity and access management and create an identity provider. Let me zoom in there real quick. Yeah, so they're add provider. And, give it a name. And this is one of the places that we're going to use the metadata file that we just downloaded from Amazon SSO. So we're going to select SAML as the type of provider we're creating, give it a name, and here's ask for the metadata document. We say choose file, and we upload the metadata document we just downloaded from SSO. And then click add provider down there at the bottom. Now we finally get to Cognito. We go into Cognito and we say we want to manage our user pool. And in there, under manage, we would say we want to, manage user pool right there. Okay, and then we say we want to create the user pool. So it's the option on the upper right there. Then we want to give the user pool a name, and you can either review defaults or step through settings. So you want to hit step through settings. There's a whole bunch of tabs that we're going to go through. Most of them you can set however you want. Here's the MFA, the multi-factor authentication. So you can implement that if you want. Then we indicate that we want to add an app client. Okay, so that's down here on this tab on the user pool. And we're still stepping through the options. So we want to give the app we're creating in the Cognito user pool a name. Ensure that we've checked generate client secret, which is usually checked by default. But then we also want to check this, which is usually unchecked by default. Enable username password based authentication, because we're going to take the username password the user has provided and pass that up to Amazon. And there's other options you can use. Social media logins, but I can't imagine doing that for production application, line of business application. You'd probably still be username password there. And then you click on the Create App Client button. And you can click through the remaining steps. We don't need to do anything more once we define the app. Okay, so now we've got our we've got the user pool we've created. Now what we need to do is we go in here and we indicate that we want you down here on the left here. You got all these tabs once again. Click on the one that says Identity Provider. Click on SAML. Once again, remember that metadata file we downloaded? There's the second place we use it. We say Select File. So we select the file that we downloaded from SSO again, and then we give this provider a name. And then you save the changes. Well, not yet, sorry. A couple more settings we need to change. So we're going to go in here. Under the enabled identity providers, we're going to click the one we just created, plus Cognito user pool. We're going to specify the callback URL. This will be the this port and IP address are the PowerServer server. And we put in slash Cognito callback. So you put that in there. Under OAuth 2, we want to make sure that authorization code grant and implicit grant are checked, as well as phone, email, OpenID, and user admin down here. And then now we click the Save Changes. This is all under the App Client Settings tab on this user pool. Now we got the user pool created. What you go on to do now is create users, or possibly import users if you've got a lot of them and you've got a file that you can generate to batch import them. Oh, a little too fast. So we need to get the client ID and client secret. And if you remember, well, actually, I guess we haven't seen that code yet, but there's a client secret that we'll be specifying. And we'll need this information when we make the call to the Cognito server within PowerServer. So make sure you go to the app clients and grab the ID and secret. And there's in the general settings, there's a couple more parameters we need. And there's a drop down up here, indicates what region we're in. So I'm in US West 2. And there's a pool ID that normally starts off with the region name. So it says US West 2 underscore and a bunch of garbled letters there. That's the pool ID. So we need those two pieces of information as well for the OAuth call. Well, well, I guess essentially it is an OAuth call, but for the call to Cognito. Okay, so now we're ready to we got Amazon Cognito configured. Let's go back into our PowerServer project. And this time we're going to say use the built-in AWS Cognito server. And I said it was an OAuth call. It's not an OAuth call. It is a JWT call. And so we are going to use, like we did for JWT, we're going to use the REST client and make sure the compression support is checked in our runtimes. So this is the code we're going to use for the call to the Cognito server. And as you can tell, it's a JSON Web Token call. It's just that we're not using the built-in JSON Web Token server. We're using the Cognito server. So everything is basically the same as you saw for JWT. Okay. What's going to change, though, is what we're going to do on the server side. So this is our CSharp code. And this is where all those values we grabbed from the Cognito user pool get used. So what we do is we go into, there's a file in here called authentication.json that got generated. And what we're going to do is we're going to add here, these values will be here, but they won't be populated with values we need. The names will be here, but the values won't be populated. So what we need to do is specify what our region is, our pool ID, the client ID secret, the client ID and the client secret. And that's used for the Cognito server in PowerServer to make the call to the Amazon Cognito server to authenticate the user. So let's go ahead and take a look at an Amazon Cognito demonstration. So this is our Cognito sample. And once again, I got the web API running in the background. I'll go ahead and fire up the client. And I thought it'd be interesting, fire up Fiddler and actually watch it in real time. So I'm logging in. And you can see the request being made for the token there. And the bearer token is created, and then the create session sends the bearer token. Okay, that's it for Cognito. Okay, so that was Cognito. Now we're going to look at Microsoft Azure AD. And it's even more different because now we don't have this piece here where we're calling calling into a service in PowerServer to do the authentication. We're doing the authentication completely outside of PowerServer. So what happens now is we're going to send a token request to Azure AD directly. Azure AD is going to validate the user, send us back a token. We're going to send that token to the Web API. The Web API is then going to also call Azure AD to get the validated token, get the token back, or the token verification back, and if it's valid, then it will go ahead and request the data and send it back to the client. So yeah, a little bit more different even than Cognito. So here's how we go ahead and set up Azure AD, which I found to be a little bit simpler than Amazon Web Services. We go into the Azure portal and we select Azure Active Directory, Azure AD. We indicate that we want to add an application registration. Except a little, oh, we're good there. Okay. We give it a name and we select the account type. Actually, I think you can read that pretty well as it is. So I've given it a name, and there's a number of different options here, whether or not you want to be multi-tenant, where you want to just use Microsoft accounts. So I've selected I'm going to use an organization directory only, and it's single tenant. Okay, so now in Azure AD, what I want to do is copy off the tenant ID. Remember, like in Cognito, we had to copy off a few ID values and then let PowerServer have them, so PowerServer knew how to do the call to authenticate the user. Same thing. We need to copy off these values, and we'll be giving them a PowerServer so it can call Azure AD to validate the user. Or validate the token, I'm sorry. Validate the token. Click certificates and secrets over here, and indicate that you want to create a new client secret. Okay. And when that secret gets created, copy it. The one thing to be watch out for here is this is the one time you're going to see that value. If you click off this screen and go back to it, you're not going to be able to see this value, and you're not going to be able to recover it. What you're going to need to do if you do that is zoom in here a little bit, is you'll end up having to delete that secret and create a new secret, and then update your project accordingly if you had ever used the values. Okay, so that's why this is in red. Make sure you grab that value now. It'll just save you a few bits of heartburn later. Okay. We're gonna go in here in the left side here and say expose an API, and then we're going to set the application ID URL. And then this dialog comes up, or this page comes up, where we add an application URI. Actually, it's given to us. We just copy it off. And we say we're going to add a scope. And we'll define the scope here. And you can put in pretty much anything you want here. You can actually create a whole bunch of different scopes. I just have one scope, just use the app scope. Now we need to go over here into we're still in the exposed in API, but we're going to click down here for add a client application. And so we'll be given a client ID. You just copy it, and it will ask what scopes you want to apply. I just have this one scope that I created earlier there, and I just go ahead and check that. But you want to copy the scope ID as well. So you've got those four pieces. You've got the tenant ID, which we saw at the very beginning, the client secret, and then these two values, the client ID and the scope ID. So now we've got our Active Directory set up. What we're going to do now is start adding users. Once we're done doing that, now we go into the PowerServer project. But what we're going to select this time isn't to use a built-in auth service. We're going to say use external auth service. Because remember from that diagram, there's nothing inside a PowerServer that's validating the users now. The user validation is done entirely in Azure AD, and all the PowerServer does is authenticate the token it receives. So when it comes to the runtimes, what I'm going to show you here in the demo, just use, I'm going to do a little too farther, sorry. Just uses OAuth 2.0 support and compression support. You actually don't need the REST client support. The reason I've got that checked there, if you go and look in the actual sample code, is I actually showed two different methods of calling Azure AD. And the reason I'm done that is because according to the OAuth spec, and I can show you that here, the client ID and client secret that are sent in the request can either come as request parameters or in the HTTP basic auth header. And it's actually up to the service you're calling as to which one of those it supports. Now, Azure AD actually supports both, so you can send it either way. Some third-party OAuth servers might not accept that. They might only accept the request parameters rather than the auth header. The thing is, the PowerBuilder's OAuth client, at least currently, only sends the auth header. So if you're working with an OAuth server that only supports the request parameters, the OAuth client actually isn't going to work. And that's why I've got that other implementation that shows how to do it during with a REST client, because with the REST client, then I could send the request parameters in the request, the way that some OAuth 2.0 servers would require it. Anyway, so that's why it's coded. That's why I'm showing REST client actually checked when it doesn't need to be. Okay, so here's the code, and like I said, for the sample I'm going to show here, we're just going to use the OAuth client. If you want to download the sample code and look at the REST client approach, you're certainly free to do that. A couple other things I'll note here. This looks pretty much like the earlier OAuth call when we called the internal server. We have the URL, the post, the client ID and client secret, the request scope, password, user ID and password. Something that's a little different here. Notice I'm tacking on a value here to the user ID. In Azure, your user ID is really in the form of an email address. It's the user ID at and then your organization. And then that has to be URL encoded to be sent on the request. Well, I've done it. I've kind of shortcutted it here. %40 is the URL encoding for at, and I'm tacking that onto the user ID because I don't want the user to have to type in this whole thing. I just want them to have to type in their user ID. And so I'm tacking this on for them. So that's what's going on there. The other thing to notice right up here, the client secret that was generated by Azure contained a tilde character. And as you're probably aware, or may not be aware, a tilde character has a special meaning in PowerScript. It means escape the next character. So if I had typed or entered the client secret that I got from Azure directly here, it would have gotten actually mangled by PowerScript because PowerScript would have interpreted the tilde as performing some sort of an escape operation on the M. And that's not what we want. So what I've done here, just to make it clear what's going on, is I've actually broken out the tilde, put in the double tilde, which in PowerScript means a literal tilde, and then tacked all the values together. So that's why that looks like that. Other than that, this is the standard OAuth request. So the next thing we need to see is what are we going to do on the C# side, because we're not using anything. We're not using a server on the in the C# code to go authenticate the request. We're just going to call Azure directly. And so what happened here with when we selected external auth server is in our authentication.json file. It just asks us what's the URL for the server we need to call. And so I've provided that value, from Azure AD. This is the URL this client needs to call. So it's login.microsoft.com/tenant ID. Remember that tenant ID we copied down off Azure earlier. Okay, that's what we. That's basically it. So let's just go ahead and do a demo of that. And this is Azure AD. So go ahead and run the client, fire up Fiddler, log in. Okay, and you'll notice what's different this time is that we actually logged into Microsoft. We didn't log into the local server. So there's our request, our bearer token, and the bearer token that we're now sending. And let's take a look at the log, see if there's anything interesting here. Yeah, I'm not. Well, let's scroll down a little bit. Yeah, I'm seeing I guess it's not logging out necessarily the calls it's making to Cognito, which is what I was hoping to find here. Yeah, so we don't see that. We just see the verification results. I'm sorry, the JWT bearer token being authenticated, but we don't actually see it interacting with Cognito. I'm sorry, with Azure. Anyway, that's it for Azure AD. And that's the end of the demos and the end of the session. So time for questions and answers.